A very good morning. My name is Priya Srivastava. So today we are from Group 7 would like to explain about the application of deep learning for fast detection of COVID-19 in X-rays using ENCOPNET model. So first of all, let me explain the project summary. So coronavirus disease has posed a worldwide risk. However, coronavirus disease diagnosis may be missed in the early stages due to its mild nature of the symptoms, where it usually takes 5 to 14 days for the symptoms to appear. So therefore, the researchers they work tirelessly to come up with a possible strategy in order to manage the pandemic in various sectors. So as a result, an alternative fast screening method using ENCOPNET algorithm, which is based on deep learning neural networks, is proposed. So convolutional neural network (CNN) has been significantly applied to extract the features which is able to train the images of coronavirus, infected lungs, and also healthy lungs. So the proposed model is able to detect the features of infected patients has hazy or shadowy patches in the X-ray images of lungs and will determine whether the individual is tested positive for COVID-19 or not. So that's all from me. I will pass to my friend.
Assalamualaikum doctor, I'm Zazan and I'm gonna present about our project motivation. In December 2019, people of Wuhan City, China got infected by the virus, which causes an acute respiratory disease in humans and also has emerged as the latest global pandemic. Later, the WHO declared as the COVID-19. The COVID-19 disease has become a raging cause of its worldwide mortality rate. The current death toll reached up to 244,000. In response to its sudden outbreak, the research and development wing of different research centers are actively participating in finding an effective diagnostic mechanism and vaccination for its treatment. And here is machine learning is used to provide the technical base and the possible solution of it. For the project field, I'm gonna pass it to my friends.
Okay, now let me proceed with project field. So basically, the deep learning based model ENCOPNET will be used in the healthcare sector. So this is due to the fact that COVID-19 is the most serious worldwide healthcare disaster in this century. So as a result, the use of CNN-based algorithm in the medical industry will aid the detection of COVID-19 diseases. It can be secured because usually in medical field, image data sets such as retina images, chest X-rays, and brain MRI provide promising results with an extended accuracy percentage when deep learning techniques are used. So furthermore, the CNN has been extensively used to extract the feature has been widely employed in medical image analysis, which has proven to be very helpful in the growth of healthcare. So that's all from me. I'll pass to my friend.
Hi, my name is Noisa Binti Azmi. So today, me and Shira will briefly discuss the brief description of the model. So firstly, the deep learning technique. So the deep learning technique are used to reveal those features of the dataset, such as image and video which are hidden in the original dataset. So for this application, the convolutional neural network or CNN has been significantly applied to extract the features. CNN is a type of artificial neural network which has multiple layers and is expert to process the high volume of data with higher accuracy and less computational cost. So the basic architecture of CNL will be shown in the next slide. As you can see, uh, the the basic architecture comprises the convolution, the pooling, the flattening, and fully connected layers. The figure also shows the input X-ray image, the network, the pooling, and the output of the X-ray. So next is the proposed model and algorithm. So okay, so the proposed model depends on the deep learning base CNN known as NCOVNet. So the applied parameter in this model are shown in the table as you can see, which it consists of 24 layers, and the first layer indicates the input layer and is fixed with 224 times 224 times 3 pixel, which make it a RGB image or color image. I'm sorry. The next 18 layers are the combination of convolution plus ReLU and max pooling layers. As you can see, as I display in the slide, ImageNet contain around 50 million annotated images from 22 different categories. So the VGG16 model is used in this application, as shown in the figures below, for future extraction as a base model. So next is the proposed algorithm. So the proposed algorithm, NCOVNet, is based on transfer learning model. So the distribution of notation used in the algorithm 1, as shown in the algorithm 1 in the left side, is shown in the left side. Okay, so for the delta 1 and delta 2 refers to the training data set and testing data set. The mu symbol, this symbol is refer to the learning rate, indicating how quickly a model adapts to the problem. So typically its value nearby to the zero. The epsilon symbol is the total number of iteration the CNN model is trained for. Also known, and it is also known as epoch. And the beta symbol is another configurable hyperparameter, generally having values in the form of 2 power of n. The algorithm output weight stored in the form of .h5 file, which are further used for prediction on a completely random X-ray image. And that is all for the proposed algorithm and model. So next I'll pass to Shira to explain further information of the evaluation performance of the application. Thank you.
Okay, Assalamualaikum. My name is Nur Shahira. So I will explain about experimental evaluation. So the first one is confusion metric, which is it is based on 4 primary parameters, which are true positive, false positive, false negative, and true negative. So this is the table that shows the rows that represent actual class values, and the attribute are the predicted or detected class values. So it is used for evaluate the performance model. So based on the test data set that using confusion metric, so it has achieved sensitivity, which is a measure of true positive of 97.62%, which is out of 42 positive patients of COVID-19, they are able to correctly predict COVID-19 in 41 of them. And then this shows that they can detect COVID-19 in infected patients through their X-ray with only 2.338% error. And then they also achieve specificity, which is the measure of true negative of 78.57%, which is out of 42 negative patients, they are able to predict that 1% is not infected in 33 patients. So this shows that they can detect infected patients through their X-ray with an error rate of 21.43%. So in conclusion, they had achieved an overall accuracy of 88.10% based on limited amount of data. Okay, next, the receiver operating characteristic. This ROC is a two-dimensional graph that shows the true positive rate against the false negative rate, or the trade-off between sensitivity and specificity. So this is the figure that show the ROC curve with true positive rate on the y-axis and the false positive rate on the x-axis. So as a consequence, in clinical data analysis study, its computation allows the data scientists to simplify data analysis using predictive medical expertise. So this is the calculation of area under cover, AUC, that done by this method. So as a result, this is a good technique to figure out how accurate the ROC provided by the model is. And then the suggested models plot AUC of ROC as shown in this graph is computed as 0.88095. So it is a good indicator of model and falls inside the good rank of classification, and is also considered to be excellent in the field of medical diagnosis. Next, the training accuracy. Okay, the proposed model had been trained for 80 epochs. The learning rate had been set to be 0.0001. Okay, in calculating training accuracy had assigned equal cost to both false negative and false positive. So therefore, the confusion metric is a better evaluation parameter as it provides the accuracy separately for each metric. But the training accuracy method also have problem, which is cannot afford to diagnose a COVID-19 positive patient as negative, and it may result in community spread of the disease. So the last one is prediction. Okay, so as shown in the figure below, applying prediction to the proposed model allows it to accurately classify the COVID-19 patient in with 97.97% confidence. So the prediction was able to produce the right answer with 98.68% confidence when applied to COVID-19 negative patient. So the measure of confidence help to only select those results which the NCOVNet is confident about. So the conclusion from the result, the NCOVNet model can be used as a substitute to RT-PCR, which take about 4 to 10 hours for detect COVID-19 patient. And then RT-PCR testing can be used in the few cases where NCOVNet is not confident about, to decrease the chance of errors. So that's all from me. Thank you.
My name is Sivaran Sukumaran. Now I'll explain regarding the project significance or outcome of this project. So as for the project used NCOVNet model, it really helps in detecting COVID-19 patient really quick, which is only under 5 seconds. As the project rate using this model is higher, which is 97.62%. The model is also easier to implement as X-ray machines almost present in all the hospital which is used this model. Patients just need to take X-ray to detect COVID-19, which is easier, a quicker way to detect COVID-19. The faster the COVID-19 detection using the NCOVNet method, it really helps in reducing the community transmission, as when they found a patient with the COVID-19 positive, they can help them for preventing them to transmit to other people who are not infected by this COVID-19. It is really significant for the country or people who have difficulty in affording expensive kits, which can be helped through this implementation of COVID and NCOVNet model, which is not really expensive compared to the expensive kits. So that's all for our project assignment presentation. Thank you.